Today's lecture is part of my series called Chemistry for Understanding Nutrition. This is on protein. And as we know, protein is of paramount importance because the minute you tell someone that you've gone plant-based, everyone becomes a nutrition expert and instantly begins to worry about whether or not you're going to become protein deficient. Who's been to a hospital within the last 5 to 10 years? Okay. To visit. You went to see somebody who had what? Heart attack, stroke, operation for something? Anybody ever been to see someone who was dying of protein deficiency because they went vegan? Yeah, I didn't think so. This is just a pretty picture of a protein crystal. So we're going to start off talking about exactly what is protein. You can't talk about protein without talking about plants, because plants are nature's alchemists. They literally conjure the stuff of life, everything that we know and use, out of thin air. I mean, plants are truly amazing. Using nothing but sunlight, water, and carbon dioxide, plants manufacture the sugars that actually give our world its shape and structure and energy. And then they take nitrogen out of the atmosphere and transform it into the amino acids that make up the proteins that make up the tissues of all living things. So next time you see a tree, hug it. Carbohydrates are plant-derived compounds made up literally of the elements carbon, hydrogen, and oxygen. And carbohydrate literally means hydrated carbon. And so you see that what plants do is they take the carbon dioxide from the atmosphere, combine it with water, and turn it into these 5 and 6 carbon sugar molecules using the energy of the sun. And these carbon backbones are then attached to nitrogen-containing amino groups to make up amino acids, which are then joined together to make proteins. The 5 carbon sugars are called pentoses. The 6 carbons are called hexoses. Everybody with me so far? Anything confusing? And if it is, don't be afraid to say so, because I'm a chemistry geek, and so I get all excited about this, but this may look foreign to you guys. No question. So if I give you the quiz that I brought with me at the end of this, you're going to be able to label all these things and tell me how they combine, right? Okay, see, I knew there was a question somewhere.
Everything is made originally from carbohydrates.
Exactly. All living things. I mean, you know, there's the rocks and things like that, but yes, all living things start off as some form of carbohydrate. All right, so let's talk about amino acid synthesis. This is like really kind of cool, because actually what happens is plants take in carbon dioxide through their leaves, but they take in the nitrogen that will eventually go into the amino acids and proteins through their roots. And they oftentimes work in conjunction with bacteria to break apart the nitrogen molecule and turn it into either NO3 or ammonium ion that then gets incorporated into the amino acids. Don't worry about how complicated that diagram is. It's just to show you that this stuff really happens. So symbiotic bacteria working in concert with the plants help them break apart the nitrogen and then incorporate it into these amino groups. And these newly synthesized amino acids are then formed into proteins. Proteins are made up of individual building blocks called amino acids. There are 20 different amino acids that make up the proteins of all living things, plants and animals. And humans can make all but 8 of them, 9 if you're a baby. And the 9 that we can't make are called essential amino acids and have to be obtained either from the diet or mother's milk. When we're babies, we really can't make taurine, but that's supplied in mother's milk. And then as we become adults, we acquire the ability to make taurine. The nitrogen in the amino acids comes from atmospheric nitrogen. Nitrogen gas is one of the most inert and unreactive molecules in the known universe. Nitrogen atoms are triple bonded to one another, and they just don't come apart for any reason. Only plants working together with the bacteria can do this. And this is the fundamental point I want you guys to take home. All protein is initially made by plants. Okay? Now, is that confusing to anybody? The point is this: if you were to trace the nitrogen in the proteins that our body makes back, it ultimately comes from a plant. So it's just like this cabinet here is made out of metal. These chairs have metal frames, and I can strip the metal frames from these chairs. I can take this cabinet, I can get a couple of toasters and maybe the frame for this screen, thank you. And I can ship all that metal to a factory that makes cars. And it can melt the metal down and then refashion it into car parts. So, but that factory did not make that steel. It only recycled it. Is that understandable? So yes, when our bodies can recycle the amino acids that we eat into new proteins, but it did not make those amino acids initially. It is only tearing them apart and recycling them. All protein has to initially come from a plant source. Meaning if all the plants in the world died off, everything else in the world would die off. So the question was, does that mean that all of the protein that we get from animals is recycled plant protein? And yes, that is exactly right. And my suggestion is to cut out the middleman. So the question was, what is the source of the bacteria that work with the plants to make the amino acids? And it's just soil bacteria. But it's specialized soil bacteria that actually will gravitate towards specific plants. And that's why I've come to understand and realize that soil, plants, these are really complex ecosystems. And it's not just as simple as sticking a plant in some dirt. You have to build up this complex web of bacteria, and even fungi are involved, because fungi have the ability to break down like dead leaves, dead wood into their minerals and old amino acids that can then be taken up by the plants and reutilized. And the quality of the soil is of paramount importance.
All nutrients come from the sun or the soil. Vitamin D, the sunshine vitamin, is created when skin is exposed to sunlight. Everything else comes from the ground. Minerals originate from the earth, and vitamins from the plants and microorganisms that grow from it. The calcium in a cow's milk and her 200-pound skeleton came from all the plants she ate, which drew it up from the soil. We can cut out the middle moo, though, and get calcium from the plants directly. Where do you get your protein? Protein contains essential amino acids, meaning our bodies can't make them, and so are essential to get from our diet. But other animals don't make them either. All essential amino acids originate from plants and microbes, and all plant proteins have all essential amino acids. The only truly incomplete protein in the food supply is gelatin, which is missing the amino acid tryptophan. So the only protein source that you couldn't live on is Jell-O. As I covered previously, those eating plant-based diets average about twice the average requirement for protein. Those who don't know where to get protein on a plant-based diet don't know beans. Get it? That's protein quantity, though. What about protein quality? The concept that plant protein was inferior to animal protein arose from studies performed on rodents more than a century ago. Scientists found that infant rats don't grow as well on plants, but infant rats don't grow as well on human breast milk either. So does that mean we shouldn't breastfeed our babies? Ridiculous. They're rats. Rat milk has 10 times more protein than human milk, because rats grow about 10 times faster than human infants. It's true that some plant proteins are relatively low in certain essential amino acids, so about 40 years ago, the myth of protein combining came into vogue. Literally, the February 75 issue of Vogue magazine. The concept was that we needed to eat complementary proteins together, for example, rice and beans, to make up for their relative shortfalls. This fallacy was refuted decades ago. The myth that plant proteins are incomplete, that plant proteins aren't as good, that one has to combine proteins at meals. These have all been dismissed by the nutrition community as myths decades ago. But many in medicine evidently didn't get the memo. Dr. John McDougall called out the American Heart Association for a 2001 publication that questioned the completeness of plant proteins. Thankfully, though, they changed and acknowledge now that plant proteins can provide all the essential amino acids, no need to combine complementary proteins. It turns out our body is not stupid. It maintains pools of free amino acids that can be used to do all the complementing for us, not to mention the massive protein recycling program our body has. Some 90 grams of protein is dumped into the digestive tract every day from our own body to get broken back down and reassembled, so our body can mix and match amino acids to whatever proportions we need, whatever we eat, making it practically impossible to even design a diet of whole plant foods that's sufficient in calories but deficient in protein. Thus, plant-based consumers do not need to be at all concerned about amino acid imbalances from the plant proteins that make up our usual diets.
So again, proteins perform a wide variety of functions in our body, including tissue building. They catalyze energy metabolism, as well as serving as neurotransmitters, hormones, and transport vehicles such as the hemoglobin, which transports oxygen around our body. Proteins are made up of long chains of amino acids joined by bonds that are called peptide bonds. And all amino acids contain, as I said, the element nitrogen in the form of an amino group attached to a carbon skeleton. And human tissues, like all living tissues, are made up of protein. So tissues as different as the clear cornea covering our eyes, the iris muscle that forms our pupil, the white sclera, the hair of our eyelashes, the cartilage in our nose, or the proteins in our skin, all made up of protein. And so what you can see is that protein is an amazing substance, because just based on the differing ratios of amino acids, you can make materials as different as hair and the clear cornea. I mean, it's really incredible. Just the idea of how you utilize protein can be compared to how you build a house. So building a body is like building a home. Your proteins are your building materials, right? So how much building material you will need depends on the size of the house, and also how many houses you're building. If you're building a new development, you need a whole bunch of build materials. If you are, some guy who's building a tiny house out in the woods, you don't need that much. So again, how much proteins you need depend on how big a building you're building, and also how fast you're building that building. So if you're building a house, but you plan to take a year to build it, do you need a semi to dump a load of building materials at the building site every week? Of course not, because you can't utilize it. So you want your rate of delivery, i.e. your protein consumption, to equal your rate of utilization, that is your growth or your repair rate. So in other words, we should only eat as much protein as we can use, because there's no advantage to eating excess protein. But there's some distinct disadvantages, as we'll discuss. Once your building is completed, do you still need that semi-truck coming around every week? No, you don't. Once your building is complete, you don't need the same amount of protein being delivered, because now you're in maintenance phase. So now you only need to get sheetrock if you punch a hole in the wall. You only need shingles if the roof starts to leak. And you don't need enough shingles to replace the whole roof, just the part that's leaking. Yes, ma'am.
I know some bodybuilders who
are eating all kinds of crap, including protein shakes, right?
protein shakes and
They're making very expensive pee and manure. Are they doing harm to themselves? Yes, they are, and we're going to talk about that. Yes, that is not good, because you're not using it as protein, and you are doing potential harm to your body. Okay, and we'll talk about that as well. Well, if you continue delivering building materials to a completed building, this is what you end up with. And an organic pile of rubble is a tumor. That's why people end up developing these things like lipomas and uterine fibroids and cysts in the breast and skin tags and skin growth, because they're delivering stuff to their body that the body really can't use, and it stimulates the body to form these benign tumors. But it can get worse than that, because you can get bizarre additions. And those are your cancers. And all of these things have been connected to and associated with excess intake of protein, particularly animal protein. And let's talk about why that is. All right, well, this is just a picture of a number of different proteins and enzymes. There are 20 different amino acids. All proteins, both animal and plant proteins, are made up of the same 20 amino acids. The differences are the differences in relative amounts. And humans have the enzymes to make all but 8 of the 20 as adults, and those 8 are what are known as the essential amino acids. The essential amino acids for humans are tryptophan, valine, methionine, isoleucine, threonine, lysine, leucine, and phenylalanine. Yes, ma'am. Okay, so the question is, someone said that we were a product of intelligent design, which is something I happen to believe. But the question is, well, if we are intelligently designed, why can't we make all of the 20 amino acids? One, that's a question you have to wait and ask God. But two, I think it's so that we could have the fun of eating. I really don't have an answer for that, except that, it takes energy to make anything. The fact that we allow the plants to make 8 of these amino acids means that we don't have to have the enzymes to make them, so we can use that energy for something else. All right, these are the other non-essential amino acids. Tyrosine, proline, glycine, histidine, serine, and glutamine. And just look how complicated these things are. Now, how many of you were at the plenary on so-called lab-grown meat? All right, remember I kept talking about how the heck do these people plan to make these things? The chemical processes for trying to make these really complicated amino acids are extremely energy intensive and use some very toxic reagents. That's why this pipe dream people have that trying to grow meat in a lab is going to be this easy, wonderful, seamless process is just ludicrous. This is not like the fairy tale of Rumpelstiltskin. You remember that? The guy would go to sleep and he'd wake up and there's all these shoes. Well, that ain't gonna happen in the lab. You're not gonna go to sleep and wake up to all this meat. What you're gonna wake up to is a disaster. This just shows the relationship between protein and carbohydrate metabolism. So if you start out with protein, you can either use the protein for structure. It can become enzymes or hormones or actual body tissues or neurotransmitters. But let's say you eat 60 grams of protein and you only need 35 for this part. Well, the rest of it then comes over here. The amino group is stripped off, and then the carbon backbone becomes carbohydrate. And it can either be burned as energy. It can be used from structures that utilize carbohydrates, or it can be stored in the form of glycogen, which is animal starch. And if your glycogen pools are full, then and only then will it go into your fat cells. But the reason your body does not like to try and turn carbohydrate into fat is that fat has a lot more energy than carbohydrate. And so it actually has to put energy into the carbohydrate molecule in order to turn it into fat. And that, again, requires a lot more energy. You have to put about 25% of the more energy into it. And rather than do that, your body would prefer to force you to burn that carbohydrate off. And so what happens when you eat a lot of simple carbohydrates? You get a Sugar buzz, exactly. That's why kids start bouncing off the walls and running around, because their body's trying to force them to burn that carbohydrate off rather than store it. Yes, sir. The question was, and in the video I showed, Dr. Greger said our body dumps about 90 grams of protein into our digestive tract, breaks it down and recycles the amino acids. Where does that protein come from? Every day, the entire lining of your gastrointestinal tract is sloughed off and digested and reabsorbed. That's where that protein comes from.
So we self-destruct ourselves every day.
Well, or it's more like renew ourselves. Yeah. Yes. So, and here are some very important points. Our bodies cannot store protein. All right, we're going to say that together, and I want everybody in this room to say this. Our bodies cannot store protein. Okay, we're going to have to say it again, because I'm looking at this guy right back here, and he didn't say it. So we're going to say it again. Our bodies cannot store protein. All right, cool. Everybody's with me. That is critically important for everybody to understand, because it doesn't make sense to eat huge amounts of steak or chicken or whatever, because it doesn't do you any good. Protein is not money. There's no bank for it. So there's no advantage to eating more than you can use.